Okay, so tables aren't that bad, right? But let's take a moment to look at graphs. So how are we going to approach that? Here's an example of two graphs, and I want to find f of g of 3 and g of f of 3. All right? The way it's going to work is actually, you want to think of it as like the same type of problem as a table problem. So the first thing you want to attack is this inner part of the problem. What's g of 3? All right, so let's come to our table and trace this out. So g of 3, what I do is I go, what do I get for an input of 3? So input of 1, input of 2, input of 3. The output I get for an input of 3 is about negative 3, it looks right? So what it's really asking for is what is f of negative 3? And that I can do, right? I come over here and I say, all right, if I go to f equals negative 3, 1, 2, 3, I get an output of about 2.5, right? And so your final answer here would be 2.5. Similarly, I could kind of do it in the opposite direction, right? So what about if my input is 3, but you remember I have to do this inner part first. The input is 3, but it's for the f graph. So 1, 2, 3. The output f gives is negative 2. So this is really asking for g of negative 2. And now I can come back to my g graph and say, well, what output does g give when I give it an input of negative 2? So 1, 2. Well, this looks like an output of about 1.5. So hopefully that answers some of your questions about composition of functions. So far we've looked at equations from the first two examples, tables from the second, and then in this last one we did graphs. And the big idea, remember, it's replacing the input of the outer function with that entire inner function, right? And that's kind of how it works in all three.